Hello, in this video, I'm going to discuss the many factors and variables that we need to regulate in order to control blood pressure. So I want to start with this sort of flow chart here to help you see all the different factors and how they relate to one another. And then I'm going to go through and discuss each one by one. So the ones in red here are the three variables that directly affect blood pressure. So that's total volume of blood, cardiac output, and vascular resistance. Cardiac output is affected by heart rate and stroke volume, which you see here in blue. And stroke volume is affected by what we see in green here, degree of stretch of the heart, the force of cardiac muscle fiber contraction, pressure required to eject blood from the ventricles. And then vascular resistance is affected by three more variables here in purple: the size of the lumen, the blood viscosity, and the total blood vessel length. So I'm going to go through each of these to help you have a better understanding of how each variable affects our blood pressure. So first off is total volume of blood. So the more blood we have in circulation, the higher the blood pressure. So think about if our cardiovascular system is a closed system of fluid, if we increase the amount of fluid inside of that system, it will increase the pressure inside of the system, and vice versa. If we have less volume of blood, we're going to have less pressure in the system. So how much volume of blood, the total volume of blood, is affected by several different things. For one, hydration status. So how much water and electrolytes are you consuming? Water is the obvious one. Yes, we consume water, we'll be more hydrated, but our electrolyte consumption is also vital to our ability to retain that water because we need to keep our water and electrolytes in balance. Then there are several hormones that affect our total volume of blood: antidiuretic hormone, aldosterone, and several others that I'm actually going to discuss in more depth in my next video. So keep an eye out for that. But we have several different hormones that affect our blood volume by changing how much water or different electrolytes that we're retaining. And some hormones also affect glomerular filtration rate, which essentially refers to how fast our kidneys are filtering our blood. So the faster they filter blood, the more we lose. So the faster we filter blood, the more water and electrolytes we lose in the urine. The slower we filter the blood, the more time we have to reabsorb those things and keep them in the body. So again, I'll discuss hormones in more depth in my next video. Diuretics also will affect the total volume of blood. Diuretics are substances that we might consume that cause us to lose more water and usually also electrolytes. Because again, we have to keep our water and electrolytes in balance. And when I say electrolytes, I'm referring to like sodium, chloride ions, and so on. And then kidney function. So healthy kidneys are going to maintain a healthy volume of blood. If there is any dysfunction in the kidneys, then that might result in slower glomerular filtration rate and therefore more retention of water and other substances. All right, our next factor is cardiac output. Now, I actually recently recorded a very in-depth video about cardiac output where I went through the different factors that affect stroke volume. So I'm going to include a link to my cardiac output video in the description below where I'll go into more depth. But the cardiac output refers to the amount of blood ejected by each ventricle per minute. We calculate cardiac output by multiplying heart rate and stroke volume. So if heart rate or stroke volume or both increase, then our cardiac output increases, which causes blood pressure to increase. So if the total amount of blood that we are ejecting from the heart goes up, then so does blood pressure. If our total amount of blood that we're ejecting from the heart per minute goes down, so does blood pressure. So we have the nervous system and endocrine system regulating heart rate and stroke volume for that matter. Okay, our last major factor that directly affects blood pressure is vascular resistance. That is referring to all of the resistance of the vascular system to the flow of blood. So, when we're looking at the movement of blood through all of our blood vessels throughout the body, vascular resistance is really referring to any obstacle to that flow of blood. So, there are three primary factors that feed into our vascular resistance. The first is the size of the lumen of the blood vessels. So a lumen is referring to the space inside a hollow organ. Usually we're talking about a tube, so like blood vessels, for example. But we also use that term in the digestive system and in other places. So the size of the lumen, the size of the space inside the blood vessels, is going to affect the vascular resistance. When we have vasoconstriction, so the lumen gets more narrow, that increases the resistance to the flow of blood. Whereas vasodilation, where we have the lumen getting larger, we're going to have less resistance to the flow of blood through those vessels. Blood viscosity, so how thick is the blood? So the thicker the blood, the more syrupy the blood, that means it's more viscous, that is going to increase the vascular resistance because thicker, more viscous blood is going to increase the friction between the blood and the walls of the blood vessel. So that's going to resist the flow of blood. If the blood is less viscous, so more watery, less syrupy, less thick, less viscous, that's going to decrease the amount of friction and therefore decrease the vascular resistance. Total blood vessel length. So the more length of blood vessels that the blood needs to travel through is going to increase vascular resistance. So what that means is larger body sizes are going to have more miles of blood vessels for the blood to travel through and therefore more vascular resistance. That also means if somebody adds body mass, whether that be muscle mass or fat tissue, whatever kind of mass it might be, if we're increasing the tissue, we're increasing tissue that requires blood supply. So we're increasing the number of miles of blood vessels that the blood needs to travel through to be able to supply that tissue. So that is one of many mechanisms, one of many factors that can connect increase in fat tissue with increase in blood pressure. It is not a one-to-one. It's not that one causes the other, because as you're learning in this video, there are many, many different ways that we control blood pressure. So just because vascular resistance increases due to increasing body mass, that doesn't necessarily mean blood pressure is going to increase, because we can also control blood pressure by decreasing in some of these other variables. So just because one goes up doesn't mean we have high blood pressure, because other variables might go down to compensate. So just to review and look back at our flow chart here, our three big factors that affect blood pressure are total volume of blood in the system, cardiac output, and vascular resistance. Heart rate and stroke volume are what control cardiac output. Degree of stretch of the heart, force of cardiac muscle fiber contraction, and the pressure required to eject blood from the ventricles are what affect our stroke volume. Then we have vascular resistance that is affected by the size of the lumen of the blood vessels, the blood viscosity, and the total blood vessel length. So these are many, many different variables here that we are controlling somewhat independently. Some of them are controlled sort of together, depending on hormonal control and other things. But more or less, each of these things we have some independent control of. And so that means that we're able to make up for one. If one is increasing blood pressure, then we can use another variable to bring it back down again, or vice versa. In some cases, we're not able to compensate, and that's where somebody ends up with chronic high blood pressure. So if too many of these variables are askew, essentially, we may not be able to control for it, and then we end up with chronic high blood pressure. All right, thank you so much for watching this video, and I'll see you in the next one.